Hey everybody, Mr. Barry here. We're now here in Unit 2 talking about analyzing quadratics. We've had a near pod already on the basics of quadratics and the parabola, our parent function for a quadratic, which is the parabola y is equal to x squared. And now we're going to be talking about three specific ways to write out quadratics that you'll see a lot of within this unit. And the first one we're going to talk about is intercept form. Which is y is equal to a times the quantity x minus p times the quantity x minus q. And hopefully you can understand from each of these different forms how much information we can get from them, both when we're doing algebra problems and trying to graph pictures, as well as when it is that we have our application problems and getting information from that. So as it states in the actual term, intercept form, the most easiest thing to pull from this particular way to write out a quadratic function is the intercepts, and specifically in this problem, the x-intercepts. So the x-intercepts will come from the following. We'll be looking in here, and much like the way that we did with absolute value functions and we got the letter h, we'll be able to pull out p and q. And from those, it will give us 2 points. So the 1 point will be p comma 0, that's not the letter O, it kind of looks like the letter O there, and q comma 0 also. And with the y values being 0 there, those things right here in red, whatever those points are going to be, will be our x-intercepts. Once we eventually get into word problems, x-intercepts are a huge deal. We'll be dealing a lot with questions that we have some sort of projectile or something's traveling in the air, and when the y value is 0, a lot of the time that will be a situation where it hits the ground, or maybe we're doing a problem with money and that's when $0 is being involved in the business at some point. So it's very applicable to those x-intercepts. I do need you to know, though, that those are the x-intercepts. Other ways to word these would be either zeros or roots. So you will see this terminology used a couple times. The zeros, it's referring to the x-intercepts. The roots, it's also referring to the x-intercepts. So it might pop up a couple different ways depending upon what's going on. That right there, 2 points already for our graph. So ideally, we're going to be probably looking at least 5 points for each time we graph a parabola. And using the idea that we have an axis of symmetry, we'll be able to use the mirror to kind of mirror off to the side. Now hopefully you realize both these y values are the same exact thing, granted it's 0. So after we figure out right away with intercept form the x-intercepts, the next thing we want to do is we would want to figure out what the axis of symmetry is. The axis of symmetry will give us guidance to getting the vertex, which would be our third point. So secondly, I want to go ahead and figure out the axis of symmetry. All right, and the axis of symmetry is going to be located directly between P and Q. So obviously right now we're just talking in generalities with letters here, but in order to find the axis of symmetry, which is always an x value, it's that imaginary vertical line running through the middle, what we would do in order to get the axis of symmetry, which is x is equal to something, we would have to add up P and Q and then divide it by 2. Or we're just going to find the middle location between P and Q. All right, formula-wise, we do P plus Q, and then eventually we divide it by 2. That would give us the x value for the axis of symmetry. That's great. That's going to definitely help us out, because once we have that information, then I can plug that axis of symmetry in up into the function in order to get the y value for our vertex. So again, now I'm getting to the third point that I'm going to be able to find. Here's 1 and 2. All right, the third point, the x value is the axis of symmetry. And in order to figure out the y value for the vertex, what we're going to do is plug the axis of symmetry into the function. So if our axis of symmetry is x is equal to 3, we take the number 3, we plug it in here for x, and figure out what the y value would be. That would be our third point. So now I have 3 points here. I got the x-intercept, the 2x-intercept, excuse me. Most of the time it's going to be 2x-intercepts. It can certainly be 1, or it can certainly be 0. But most of the time it's going to be 2. All right, here we figure out our third point, which is the axis of symmetry. Finally, to get the last 2 points, we do want to use the concept of our axis of symmetry. Now that we know the vertex and the axis of symmetry, we can go ahead and use that mirror. And the most easiest way to do that is by now finding the other intercept. So we have a couple x-intercepts here. Now, in the third installment, in the third step to this problem, we're going to go ahead and figure out the y-intercept. So third here, we're going to find the y-intercept. Now for the x-intercepts, the y values were 0, and the flip-flop that for the y-intercept. So in order to find the y-intercept here for this particular function, whatever comes up, what we'll do is we'll plug in 0. Plug in 0 for x into the function. So up here we'd have whatever the number is for a, 0 minus some number, times 0 minus some number. We'd calculate that out and we get the y value. That would give us our y-intercept. From there, we would have 4 points now, the 2x-intercepts, hopefully 2x-intercepts. The axis of symmetry would lead me to the vertex, that's point number 3. And then finally, my fourth point comes from the y-intercept. After I have the y-intercept, what I'd like to do then is to use my mirror, and using that axis of symmetry, which is a mirror, get the fifth point. So there's a lot of certain pieces of information here that we'll go through. Obviously, this would make a little bit more sense once we actually do some math problems, which is coming up in this Nearpod. But for now, again, we have our intercepts that come up from the x-intercepts first. We use those x-intercepts to decide what the axis of symmetry is, which would lead me to the vertex. Then I go ahead and figure out the y-intercept. That would be my, in a lot of our word problems, what's initially the situation, so an initial height or an initial distance of some sort. You'll see a lot of that terminology in word problems. And then finally, once I have my y-intercept, I can use that y-intercept and the mirror to figure out a fifth point, which we'll talk about this a little bit more when we get into some algebraic examples. So plenty of information here given by the intercept form. We want to make sure that we use it as much as possible when it comes up in this second unit.